Good day, everyone. Today we are getting to the unit circle and the Pythagorean theorem for Algebra 2. Alright, for those who are in the classroom, today we are going to do our math rotation. Our math rotations in the classroom usually take an hour. You're going to meet with me, meaning that we're going to do guided instructions together. A, it's going to be all together. And when we get to A, it's going to be more you doing the work than I am. I'm not going to be doing much of the work. I probably, at most, will provide you feedback. So I need for you to do not come to me with blank papers. I need for you to come in, have some work situated, ask your questions to your people first. After you ask 4 people, 5 people, then come see me. Don't see me just because. 4 or 5 people first, then me. Technology. So the technology is because the Chromebooks are now taken from you guys. You're going to be doing little calculator assignments, or our Kahoot's going to be done in a different way. That's probably going to be in the technology section. H is more hands-on. There's more of a personal thing for you to do. It's not something that you and 50 people are going to do together. No. And you choose to be not compliant to that, you do get 0 for that particular part. So you're going to have 4 grades in this rotation. Alright, 4 grades. So try not to lose any points in each of those grades. Because again, the 8 being hands-on, that's going to always be the little quiz session. And some of you guys, I may pop you off there. Right in H. Now, because of the heat also, we may be doing it all together as a class. I'll try to put you guys in groups, but with all the heat that goes on, it's going to be a little too hot. And then when you move, you're going to be burning up. Alright, so this is nothing important, but today's learning objective is just using trig ratios because we're going to start creating the outer part of the unit circle. Also with those special triangles too, but all that stuff that is just written there, that's not to be worried about. Also, just for a little reminder, people, even if you are at the house, you are still responsible for the work. You are still responsible for the work. You. So make sure when you're not here, you go jot down some notes, have some notes ready, because bond checks are still happening. To achieve in math, I know many of you guys think it's just showing up to class, you get it, you pass. Not gonna happen. Unless you are a really fast learner, because I do have a few of those in the class, homework has to be mastered. I know because now we're going back to paper, you guys going to copy off each other and not really demonstrate skill. And those pop quizzes I was telling you about, they're happening every day. So just be ready. So, as the saying goes, stay ready so you don't have to get ready. Watch those videos. Again, these videos are not for me in particular. These are your defensive tutoring because when I get to my final grade, my question is going to be, did you watch the videos? If you did all that, and I'm going to know about you commenting on them, then you may have a little case. Alright? Come to tutorings. So you guys, I may, because of the whole no one have their Chromebooks to go home with, we're going to have to figure out some other ways. I'm still going to provide it online because some of you guys do have the technology to do it. If you don't, you can still come to other classes to get your tutoring. But please be aware, you are not to come to my classes acting up. So you get put out if you come to second block, decide to go cut up and blah 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 will throw you out. Do not cheat. I'm not. You guys know I don't tolerate that. I'm not a big fan of it. I warned many of you guys. Many of you guys came forward for cheating, which I was thankful for. But if it happens again, you're gonna get those 3 days. I'm gonna push to make sure you get all 3 days. This is ultimately what we're going to create. And we're going to create that by using our special triangles that we've been working on so far. The 30, 45, and 60 degree triangles. Yes, all of that. All right. We get into all that, we got to talk about ratios right quick. The trig ratios. You guys know about SOHCAHTOA, sine opposite over the hypotenuse, cosine adjacent of the hypotenuse, and then tangent being opposite over the adjacent. Well, they're gonna have their inverses too. Like the inverse of sine being opposite over the hypotenuse is going to be called cosecant. Cosecant. So that means the hypotenuse over the opposite. Cosine. We know cosine is adjacent over the hypotenuse. Well, its inverse secant is going to be hypotenuse over the adjacent. Tangent is going to be opposite of the adjacent, but its trig inverse cotangent is the adjacent of the opposite. So, alright, so you're going to be tasked to find all of the 6 trig ratios we just talked about. But to do that with a triangle like this, you have to find the hypotenuse. And we know by using the Pythagorean theorem, we go 4 squared plus 3 squared. And when we square both sides, add 16 plus 9, we get 25. C equals 5. So we knew that with our problem. So the hypotenuse is going to be 5. So now let's go ahead and start finding what sine is. Sine is opposite of the hypotenuse, which is 4/5. Cosine is going to be not 4/5, but 4/3. Well, it's actually 3/5. Sorry. So it's going to be the adjacent of the hypotenuse. Then tangent is going to be 4/3. And of course, when you do cosecant, you just take the inverse of it. So 4/5, the inverse of that should be 5/4. And then the cosine inverse is called secant. And that's going to be not 4/5. That's going to be 5/3. And then we know that the tangent is 4/3, so its inverse is going to be 3/4. And we just found our 6 trig ratios. Now, when you get my quiz, remember, I'm not giving you a angle chart with those particular details. All right. These are pictures of what we knew already about the 30-60 triangle, 30-60-90. We know that the ratio is going to be the leg. From the short leg, it's going to be just the leg. And we could rotate this triangle like this if we wanted, meaning that we could have the 60 degrees stand right here, or we could lay it flat, it does not matter. And then the hypotenuse It's always, 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 always twice the short leg. So it's going to be twice the short leg. And then the tallest leg is going to always be x square root 3. All right? And then in 45, 45, we know that the short and long leg is going to have the same length. And then its hypotenuse is going to be the same length as the leg times the square root of 2. All right, before you go, we just got another thing about square roots. Square roots, we know we cannot have a negative number in the square root because it's not real if we do it. All right? But just do not forget, you guys, the inverse of x, square root of x is going to be x squared, and vice versa. So if I have x squared, the inverse is going to be square root of x. This is critical when we're using the Pythagorean and trying to find size and stuff. Now, we're going to have to rationalize the denominator next, which I'm going to tell you what that's about. So let's go over this right quick. What's the inverse of square root of x? X squared. What's nowhere around the square root of x? You don't need to worry about that at this moment. We're going to get to that later in the school year. So what's going to be parentheses 5 square root of 6 squared? Well, I already told you what you have to do. This exponent 2, use your distributive property, multiply the exponent by both of those. So 5 squared is going to be 25. Square root of 6 times the exponent 2 is going to be just 6. 25 times 6 is going to be 150. Just like that. Alright. Oh, I'm going a little too fast. So, when you're dealing with trig stuff and you're dealing with radicals, you're going to learn how to simplify them like 108. What I mean by simplifying, that means that at least one of its factors inside the square root are going to have a perfect square. A perfect square is a number that is multiplied by itself to give you another number. Like, for example, 4 is 2 times 2, and of course, 36 is 6 times 6. Alright, so let's get back to 108. So when I'm breaking it down, I know that 36 times 3 gives me 108. But I also know that 36 is a perfect square, and 3 is not. So square root of 36 is 3, and then that 3 that is not a perfect square, everything, leave it alone. So 63, I know 9 times 7 does give me 63. 9 is a perfect square, but 7 is not because 9 is a perfect square. The square root of 9 is what? 3. And then the square root of 7 is going to be 7. Now listen up. You see how you got square root of 3 and the square root of 7? It's because we were breaking down the number. Neither of these are perfect squares. So when you break this down, wherever it is not a perfect square, you're going to keep inside the square root. So let's do 76. So when I broke down 76, I broke it down as, it's not 4 times 9. I'm so sorry about that, y'all. While I was trying to type in my stuff. I'm so sorry. So it should have been 4 times 19. I don't know why the 1 It didn't go nowhere. So we know 4 is a perfect square, but 19 is not. Because 4 times 19 gives you 76. So the square root of 4 is 2. And then 19 is not a perfect square, so therefore it is left to be 19. Again, anything that does not have a perfect square or is not a perfect square, you leave inside the radical. Anything that's not a perfect square, you leave inside the radical. Anything that is not a perfect square, you leave into a radical. And anything that is perfect squares be pulled out. Alright, simple rationalizing radicals. Yeah, there's this mathematical law that states that when you have a radical in the denominator, you can never ever, forever ever, for never ever ever have any denominator. So to take care of that, you have to multiply both numerator and the denominator by the square root of 4. And when you multiply by that, you will multiply across. So 1 times square root of 4 is just the square root of 4. And then 4 times 4 is square root of 16. So, so the square root of 16 is what? Square root of 16 is 4. Also, the square root of 4 is what number? 2. So you can simplify that to 1/2. Right, so let's try this one. So to do a problem like this, multiply the whole entire thing by the square root of 5. And when you do that, the denominator is going to be the square root of 25. And then because when you multiply 3 times 5, now here's where it gets interesting. Because 3 is not a square root, you're just going to leave 3 alone. Again, because 3 is not a square root, leave it alone. So it's going to be 3 square root of 5. Now let's simplify the square root of 25. It's just 5 and 3 square root of 5. You cannot get rid of the square root of 5. You cannot divide square root of 5 by 5 because in order to do that, both of those got to be square roots. Alright, and don't forget about these triangles, the 30, 45, 60.